Okay, so welcome back, DP students. This lesson is for both HL and SL. The first bit is going to concentrate just on stuff for SL, and then the second half will be for HL only. Okay, so first half SL and HL, second half HL only. So before the break, we looked at the cosine rule, and the cosine rule enables us to find a length or an angle for any non-right angled triangle. Okay, so it has to be non-right angled. Actually, it doesn't have to be. It will work for any triangle, but we use it for non-right angled triangles. So the cosine rule says if I want to work out length A, I say that A squared is equal to, so if I want to work out this side, it's going to be B squared plus C squared. So B squared plus C squared minus 2 times B times C times the cos of A. Okay, so remember we use the lowercase letters for the side lengths and we use the uppercase letters for the angles. So remember, if you want to find a side, all you need is the other two sides and the angle in between them. So if I want to find side A, I need to know this side, and the angle in between. If I want to find, let's say I want to find out what B is. So if I want to find out this side, I need to know this side, and the angle in between. So it would be C squared plus A squared minus 2CA times the cos of the angle in between C and A, which is B. And similarly, if I want to find C, I need to know, well, B and A, two sides, and the angle in between. So the formula would be C squared is equal to B squared plus A squared minus 2BA cos of the angle in between B and A, which is, of course, C. So you can remember this formula, but the way I always kind of think about it is if I know two sides and the angle in between, I can find the other side. And remember as well, if you know two sides and the angle in between, you can also find out, just as a bit of a recap, the area. So that enables us to find out the area, which would be a half A times B times sine of the angle in between. Okay, so half AB sine C. So that is for the area. And remember, these formulas are given to you in the formula booklet, so you do not need to remember them, but I encourage you to do so. Okay. Now, if I want to find an angle, easy enough. All I'm going to do is to take our formula. Let's say A squared is equal to B squared plus C squared minus 2BC cos A. And what I'm going to do is rearrange it for the angle. Okay, so first thing I'm going to do is subtract off B squared from both sides. So I'm going to get A squared minus B squared is equal to C squared minus 2BC cos A. Then I'm going to subtract off C squared from both sides, because remember the aim here is to get the angle by itself. So I get A squared minus B squared minus C squared is equal to, so when I subtract C squared off this side, I'm left with negative 2BC cos A. Now, what is the negative 2BC doing to the cos A? It's multiplying, so to get rid of it, I'm going to divide both sides by it. So divide both sides by negative 2BC. So that leaves me with A squared minus B squared minus C squared divided by negative 2bc, and that equals cos of A. And I can tidy this up a little bit. Cos of A is equal to, now if I divide, I'm dividing here by a negative number, negative 2, okay? But if I divide through by the negative, that's going to make the negative b squared, that's going to make that positive b squared. The negative c squared is going to become positive c squared. And the positive a squared is going to become negative a squared. So what I'm doing is I'm dividing each term by the negative part, okay? So divided negative b squared, negative c squared by the negative, that gives me positive. Divide the positive a squared by negative, I get the negative. Do the same on the bottom, divide this by the negative, and it becomes positive. So I get 2bc. So that is the formula for finding the angle. Okay, now that is how it's given to you. Obviously, if you want to find the angle, if cos of A is equal to this, in order to find just the angle A, well, how do you go about getting rid of the cos function here? We have to do inverse cos. So you would do inverse cos of all of this. Now, the formula is not given to you like this. The formula is given like it is here in the red box. So this is how you're going to have to kind of think about it, okay? So in terms of doing a question with this, okay, let's have a look at one. Okay, so here's our question. In triangle PQR, PQ is 9, QR is 16, PR is 11. We have to find the smallest angle in the triangle to the nearest degree. Okay, so we're not specifically told which angle to find. So first thing we're going to do is to draw it. Okay, so I'm just going to randomly sketch it. So here is, let's say that this is PQ. PQ is, we're saying 9 centimeters. And then I'll need to draw in QR, which is 16. So, I don't know, let's say, it doesn't really matter how I draw this, as long as I'm getting an idea of what it looks like, okay? Because how it's going to look is going to help me. QR, we're saying, is 16. And then the final length, PR, is 11. Now, so there's my diagram. We have to find the smallest angle in the triangle. So which one of these is the smallest angle? Looking at my diagram, well, this one looks like the biggest. Then this one looks like the next biggest, and then this one looks like the smallest. However, that is not the case. Why not? Okay, it is to do with the side lengths, okay? This is the longest side, 16, so that means this is going to be the biggest angle. The next biggest side is this one, 11, so that means the angle opposite that is going to be the next biggest. The smallest side is 9, so this is my angle that I'm after. This is going to be the smallest angle, okay? So remember, the smallest angle is going to be opposite the smallest side. Smallest angle opposite smallest side. Keep that in mind. Same thing, if it's the largest angle, it will be opposite the largest side. So this is what I'm after, okay? And we can call that is angle R. That is what we're after. All right, so using my formula, and let me just pull up the formula again. Okay, so here's the formula. This is what you get given, of course, in the formula booklet. So let's see if we can apply this formula to the question. Okay, so we want to find angle R. So it's cos of the angle. So that makes sense. It's going to be cos of R. is equal to, so we said that cos of angle A, so we were looking at, this is the angle we're finding in the formula, it's equal to b squared plus c squared, first off. So it's the two sides that are surrounding the angle. So this is what I'm finding. So the first part is going to be 11 squared plus 16 squared. And then it's subtract, well, it's subtract the other side, okay? So b squared plus c squared, subtract the side opposite the angle. So it's going to be subtract 9 squared. Then divided by 2 multiplied by BC. And BC, remember, those are the angles that are surrounding the angle that we're trying to find. Sorry, BC are the sides that surround the angle that we're trying to find. Okay, so BC are 11 and 16 because they're surrounding angle R. So 2 multiplied by 11 multiplied by 16. And we can put this into our calculator. So I'll bring up my calc. Okay, so in order to put this in, we're going to be careful, okay, because if I do the following, 11 squared plus 16 squared, oops, that's not plus, minus 9 squared, and if I just do divide like that, I am not going to get the correct answer because I'm only dividing the 9 squared. I need to divide the whole top line. So I can either use brackets, which I can put in like so, or you could do each part individually, okay? You could do the whole top line, it equals, and divide that answer by the whole of the bottom line. But I'm just going to do it all in one. So top line divided by the bottom line, and I'm using brackets for the bottom part as well. Okay, so that equals that. And what I'm going to do, just to show the examiner, 0.86, what was that? Sorry, 8409. .8409, and then to find R, I'm going to do the inverse cos of that. But when I put it into the calculator, I am going to use the full answer. And let me just make sure my calculator is on the right setting. Degrees. Yep. So I'm going to do second cos, so get inverse cos, and I want the previous answer. So cos of the answer, and to the nearest degree, 32.7, so I round up, it's going to be 33 degrees. Okay. Okay, so SL, you can have a go at practicing some of these. So the questions that you did last time on the cosine rule, I asked you to go have a look at page 491 in the book, and you did question 1, so that's finding the missing side lengths. Now you can do question 2 onwards, okay, so question 2 up to 6, so I would definitely have a look at those, please, okay, so do those today, please. Thank you. So right, so that was for standard level. HL, if you need to practice this, which may not be a bad idea, you're on page 393, and that's exercise 6G, okay? Question 1 to 5. That is for HL, so that's what you can have a look at to practice these.